Hi everyone, this is the Algebra 1 final review. And again, do not do this. This video is not to be meant to be watched from beginning to end. It's just meant to be watched problem by problem, or you can do it end to end, I suppose. But you should be doing these by yourself. And if you have a question, that's when you look me up, okay? Or if you're like, I don't know how to do this. Okay, so here we have the domain and the range of every graph. And for the first one, let's make domain. Let's make it blue. Okay, so the domain talks about all the x values of this graph. And if you notice, so if you look at this graph, I would go all the way to the left. The furthest part is right here. On goes all the way through to right here, right? So it's going from, so we'll say domain like this. And then, so it's going to be referring from -6 is greater than, oh, sorry, -6 is less than x, which is less than +6. Like that. We're not going to put equal to because they have an open circle on both sides. So it can't equal -6, but it can be anything in between -6 to +6. Be 0, it could be 1, 1.5, anything like that, all the way up until 6. All right, and then we've got the range, so that's going to make that orange. And it's going to be anywhere, let me see this. It's very thin. And if you look at the lowest part right here, it's at -1. It's going all the way up to +2. So this is the highest point. This is the lowest point. We have everything in between that, right? So we're going to say the range. So what can y be? It can be as low as -1. Can't be -1, but anything right up to -1, like -0.99999. It could be all that. So y, so -1 is less than y, which is less than 2, and you see all the way up to 2. And notice here, it's just a point. It can be 2. Y can be 2. So it gets less than or equal to 2. Just like this. There's the domain and there's the range. Just describing what are all the x and y values. Okay, we're moving on to number 2. So again, domain is talking about the x values. And if you notice right here, there's only one x value x can be is 4. Right? It doesn't go to the left. It doesn't go to the right. It just stays right there. So domain is x equals to 4. That's it. There's nothing x can equal to. It's just 4. Let's see here. Got a range. So ranges are y values. Oh, can't really see that. Well, Decker. I'm gonna go like this. There we go. So you can see it a little better. So y range is going to be anywhere from -5. So it can be -5, less than or equal to y, which is less than 6. Again, at 6, it cannot be 6 because there's a hole at 6. It's an open circle, which means cannot equal to. And there's your range. Number 3. All right, so at 3, we're going to talk about our domain. So the far left part is going to be right here at 0. You see it like starts right here at 0 and goes all the way up to 4. We're not looking from end to end. We're looking about furthest left and furthest right. That's all we're looking for. And if you notice right here, domain, we go all the way from 0. At 0, it's an open circle, so less than x. And on the very right, this is going to be less than or equal to 4. Just like that. Remember, we're always going smallest number first and then biggest number. So first is the 0 and then it's the 4. Our range is going to be, it goes as far as -6 below, and we're going to go up to +6. So range, we have from -6 it can equal to because it has a closed circle, less than or equal to y, which is less than, not or equal to, because it's open right here at 6. Okay. So if you notice right here, domain and range always have these less than symbols on here. They don't, what is it? Less than symbols, they don't go through. All right, domain. Last problem for domain. Again, if you have not tried to do these by yourself, I would pause, try it by yourself, or do all these problems with me, and then try it by yourself again. Okay, like do it on a separate sheet of paper. Domain, we go all the way from -4 to +6. So at -4, it is open. So just -4 is less than x, which is less than or equal to 6. And our range is going to be all the way, it goes as low as this 0 right here. Don't look at the 2 value because that's the x value. And then we're going to go all the way up to 3. So from 0, which is less than or equal to, there's no open circle there, y, which is less than 3. There we go, just like that. All right, there's domain and range. We're going to go into solving equations. The first set of 4, okay, we're working in sets of 4, though. So the first set of 4 of these equations are just two-step equations. That's the basic. You need to know this. If you don't know this, sad days, practice more. Again, solving equations, it's the reverse of order of operations, right? So thinking, remember we normally do, if we're going to like evaluate something, normally the multiply and divide that comes first, you do that left to right, and then we add and subtract. And that goes again left to right. Notice right here, we're going to, so since we're evaluating, we're going down this way. Evaluate. So since we're simplifying, solving, right? So when we're solving for x, it's the mystery, right? We've already have the answer. Answer is 7. We're going to see what it was before, right? So we're going to do the reverse of order of operations. So we get rid of the add and subtract, and then we get rid of the multiply divide. So if you see right here, we have an add 9. So what are we going to do? Our answer is 7, and we're going to see what x is. So we're going to undo our +9, which is, we do that by subtracting 9. And then we get, so x over 8 is equal to -2. And then what do we do? So we're going to, now we have this, remember this line means divide. The opposite of dividing by 8 is multiplying by 8. So remember, it's some number divided by 8 is going to give us -2. What's that number going to be? It's got to be a bigger number, right? So now my 8s are going to cancel out because 8 divided by 8 is 1. All I have is x. -2 times 8 is -16. Yeah. If you were to plug it back in, it will, so -16 divided by 8, which is -2, plus 9, which will give us that 7 back again. Okay, simple. Again, just keep on practicing. Here again, right here, we have this two terms are split up until with these minuses. So we're going to get rid of this -5, which is going to be adding 5. Done. And then we have left this -5n is equal to -75. And now we have this division. So -5 times some number is equal to -75. You know what that number is? That's what n is, right? But if you're like, I don't remember what that is, we're going to just, remember, divide by -5, because -5 times some number, we're dividing it, and we got n is equal to 115. All right, you could use your calculator to figure that out, or your head, because you've practiced your times tables, right? All right, number 7. And this is the last two problems of a two-step equation. We have this -6. Remember, we don't want to get rid of the multiply first. It's getting rid of the -6, so it's +6 on both sides. And then we're going to r is equal to -18. And then we're going to now 2 times some number is equal to -18. What is that? Don't know. You're gonna have to follow me, and we're just gonna divide both sides by 2. And we have r is equal to -9. Because -18 divided by 2 is -9. Last problem for this set. 2 is equal to 1 plus 9 n over 9. So again, we got this 1 here. Subtract 1 on both sides. These kind of problems a lot of people get confused on. The reason why is because they were just like, oh, over 9. So they just do over here divided by 9 as well. And they're like, it's not how we get rid of this, right? It's already dividing by 9. So we're going to do the opposite, which is multiplying by 9. And that's going to be 9 is equal to n, or n is equal to 9. Same thing. Okay, now we're going to go to the next set of 4s. Now, these types of problems are not two-step problems. They will become two-step problems. But if you notice right here, we have variables on both sides. So what we're going to have to do first, we're going to have to rewrite them. I notice right here, we can simplify the right-hand side. We can combine like terms. That's what we're going to do first. So 2 plus 7b. We don't need to simplify. It's already simplified. They are not like terms. But right here, the 6b and 2b is 8b, right? 6 plus 2, 8. Since they both have b's on there. Now what we're going to do is we're going to get the variables together. I like to do it that way just because it's less work. So what we're going to do here is I have the number 2 over here on the left. So I'm going to get rid of this 7b. And the way I get rid of a plus 7b is subtract 7b. Subtract 7b, and I have left 2 is equal to 8b minus 7b, which is 1b, or you can just say b. Remember, we don't really need to write 1b. We can just say b. Same thing. So b is equal to 2. Actually, not bad. This was in a way kind of like a two-step equation. It took 2 steps, right? We combined like terms, and then we got the b's on one side, and it was already solved for us. Here, I noticed that the left-hand side, we can combine like terms here. So that's what we're going to do first. So I have 5k. 8 minus 5 is plus 3 is equal to 7k minus 5. And I notice that some people have like a preference of always bringing the variable on the left. You do not have to do that. If you're trying to avoid negative numbers, then you're going to be like, okay, I'm going to subtract out the smaller of the k's. If I have 5k here, I'm going to subtract 5k. Subtract 5k. If you wanted to subtract 7k on both sides, you totally can do that. It's not even a problem. And we have 3 is equal to 7k minus 5k, which is 2k minus 5. Now, we're back to our two-step equations. We're going to add 5 to both sides. So plus 5, and we get our answer of 8 is equal to 2k. And now we're going to divide by 2. And we get them running out of room. And just be like, it's over here. K is equal to 8 divided by 2, which is 4. Boom. So if I were to plug this k back into here, we would get the same answer. For example, like I would do this on the test. If I had time, 5 times 4, which is 20, plus 8, 28 minus 5, which would be 23, right? And 4 times k, 7, which is 28 minus 5, which is again still 23. So yeah, we still get it. We get the same thing on both sides. This is the k can only be 4. We want this to be equal. There's only one solution. All right, and here are the second 2. I notice that we have k's on both sides, but there's no like terms to combine, so I'm going to right away just be like I'm subtracting 3k. And remember, I have this minus 8, so I'm going to get rid of the other term, so the variable on this side. So I can subtract 7k on both sides, but this is just going to require one less step if I do it this way. So 7k minus 3k is equal to 4k minus 8. And if you don't believe me, then just try it out. Okay, so subtract 7k on both sides and see what you get. Divide by 4. So these steps are going to be, the more you do it, the more you'll realize it just repeats this. It's similar steps almost every time, right? But you need to expose yourself to different kinds of scenarios and different kinds of situations. All right, so again, right here on the left, we have negative 6a minus 6a. Do not say 0. They do not cancel out, right? You have negative 6 and you're subtracting 6, you're at negative 12a equals, and I got these like terms over here, 14 minus 6a minus negative 6a minus 8a is going to be minus 14a. Don't get fooled by those negatives or those minuses, right? And then, so since I have my 14, just my regular numbers here, I'm going to get rid of this 14a by adding them together. And then I have 2a is equal to 14 divided by 2, and I get a is equal to 7. Right, so that is variables on both sides. There's no distribution. You're just combining like terms and then solving for x or sorting for the variable. It doesn't have to be this. Okay, we're going on to the next 4. And these are, again, solving for x, but now we have parentheses, so we're going to figure out the distribution. Okay, so 2 ways to get rid of this parentheses. First way is to distribute. That's most common. Second way, if this negative 8 is divisible by, the negative 176 is divisible by negative 8, you can do that as well. You can divide it out. I'm just going to use the standard procedure way. We're just going to use multiplication. So we're going to distribute. So negative 8 times 2p is going to be negative 16p. And then negative 8 times 6 is going to be negative 48. All right, from here, what are we doing? Now, again, look, to see how it is, it's a two-step equation again. Told you, it always boils down to a two-step equation. Plus 48 on both sides. And this is going to be negative 1, 30, 28, 128 equals negative 16p. So we're saying that negative 16 times a number is going to give us negative 120. So now we're going to divide by negative 16 because I don't remember what that is. And we're going to get p is equal to, it's going to be positive. 16 doesn't go into 12 evenly, so it's going to get into 120. Maybe 6 times? No. 7 times? 8 times? Okay, we're going to have to use your calculator. Okay, let's go down here. And we got 128 divided by 16. Oh, it is 8. Right there, 8. I don't know if you can see that. I'm in a tiny corner on the top of your screen. So here, 8, just like that. All right, and we're going to, okay, I'll show you here how to divide if you wanted to. Well, you can't do it. This one is a little bit more complicated, so you can't just do it here. If you notice right here, we have this minus 5, so if you were to divide by 8, I'd have to divide the 5 by 8 as well. And that's like 5/8, and then you're going to deal with fractions. It's not great. Okay, so I'm just going to distribute here. So 107 is equal to negative 8 times x. Negative 8 times negative 7 is going to be positive 56 minus 5. I got these like terms on the right-hand side, so we're going to figure that out. We're going to combine them together. So -8, and this is going to be plus 51, right? Because 56 minus 5 is 51. Again, we're back to a two-step equation. We're going to subtract 51 on both sides. And then we get 56 is equal to -8x. And we're going to divide both sides by -8. And x is equal to 56 divided by -8 is going to be -7. Okay. Again, we're going to, right here, we're going to just distribute because we've got these parentheses. We've got to get rid of that first. And then we can start doing what we're doing. So 96 is equal to 5. 5 times 1 is 5. 5 times -2n is -10n. Then we got -3. Right, now I got some like terms on the right-hand side. So we're going to just rewrite that. So 96 is equal to 5. And then -10n minus 3n is going to be -13n. Then we're back to our two-step equation. So we're going to subtract 5 from both sides. We got 91 is equal to -13n. And we're going to divide both sides by -13. And we get n is equal to -6, 7, -7. And look, honestly, what I'm doing right now is I know I have to multiply the 13 times some number is going to give me a 1 at the end, right? So 3 times, if I was trying 8, but I know that 3 times 8 is 24. So the ending can't be right? So I went to 7 because I know 3 times 7 is 21. That would give me the correct number on here. I know they're all integers, but just in case, just so that you can see it, 91 divided by 13 is going to be 7. All right, so there's -7 for you. Also, you may have noticed that I just switched the n to the left-hand side because normally we like to say the variable first and then what it's equal to. And since they're equivalent, you can just switch them, right? Like for example, here, if you like to have the variable on the left-hand side, you could just say 8 times b minus 7 is equal to -96. You see how you just switch that, right? The whole thing. Everything on the left goes to the right. Everything on the right goes to the left. And you can do it like that. All right, we're going to distribute 8b minus 8 times 7 is going to be 56 is equal to -96. Now, again, we're just solving. So plus 56 on both sides, add 56 on both sides. And we have 8b is equal to -40, right? What's b going to have to be? B times some, 8 times some number. It's going to be -40. What would that be? -5, right? So here, let me show you. So b is going to be -40 divided by 8 is -5. All right, moving on to the next 4 types of problems. We have here variables on both sides, and we have parentheses. So we're going to have to do a few steps first before we get to our two-step equation, right? So 4 times x is 4x. 4 times 3 is 12, so plus 12 is equal to -4 plus 6x. Now I have to get rid of the variable on both sides, so it's going to have to be -4x minus 4x. And that gives us 12 is equal to -4 plus 2x, right? 6x minus 4x is 2x. Now we're back at our two-step equation. So we're going to add 4 to both sides. All right, so 12 plus 4, that's going to be 16 is equal to 2x. And then divide both sides by 2. We get x is equal to 8. There we go. Again, we're going to try it again. Okay, again, pause. Do it yourself. You got to let your brain think. Okay, so -2 times 8k is -16k. -2 times -2 is going to be +4 equals 26 minus 5k. All right, we got variables on both sides. So we're going to get them on one side. So I'm going to get rid of this minus 5k. If you wanted to get rid of the minus 16k, you totally could have done that too. Either way is totally fine. And we got -11k plus 4 is equal to 26. Again, we have our two-step equation. We're going to subtract 4 on both sides. And we have -11k is equal to 22. And we're going to now divide both sides by -11 because we want to know what is just k. And we'll be like, k is equal to -2. And, ooh, look, this is the last part of our solving equations. Again, learning how to solve equations, that's really going to help you with the next levels, like in geometry and algebra 2. Right? A lot of people don't do well in geometry because they don't know how to do the algebra, which is very weird, right? But they don't know how to solve for these things, right? You're going to come up with these kind of equations and you're like, I don't remember how to solve this. That's why we got to learn this in algebra 1. All right, so here we go. Again, we got parentheses. So we're going to just figure that part out. So -2 times 8k is -16k. -2 times -3 is +6. And then I'm going to add 16k to both sides. We got 6 plus 18k is equal to 6. And we got our two-step equation again. So we're going to get rid of this left-hand side 6 by subtracting 6. Boom. We got 18k is equal to what's 6 minus 0? 6, 0. Right? A lot of people are like, oh, no solution. Don't do that. All right, this is 0. And now we're going to be, okay, 18 times what number will give you 0? There's only one number, 0, right? And so we're going to divide both sides by 18 for those of you guys who like, you like routine. So k is equal to 0. That is the solution. That's a number, right? A lot of people are like, they get freaked out when they see 0. Don't be like, it's fine. All right, so -5 times a, -5a, -5 times 4 is going to be -20 is equal to -6a minus 18. I'm going to add 6a on both sides. Oops, not that. So add 6a on both sides, and you get why is it not changing for me? Anyways, so -5a plus 6a is going to be just a. So you can say 1a, but we know that 1a is just the same thing as a. -20 is equal to -18. Look, it's now a one-step equation. You know why it's called a one-step equation? It's just one step, right? And so we're going to add 20 to both sides, and we get a is equal to 2. Done. Since a didn't have any coefficients, there was no other extra numbers out there. It just turned into a one-step equation. All right, we finished our equation solving. Now we're going to do inequality solving, right? So now instead of having equal sign, we have an inequality, like going one or the other ways. We're going to solve it the exact same way. Okay, very little changes. All right, we're going to just rewrite this. So you've got parentheses here. We're going to distribute them, right? So it's going to be -156 is less than 30r. 6 times 4 is going to be plus 24, right? And this is a two-step inequality. Really? See, that just doesn't want to change. We're sticking with orange then. So now we're going to just subtract. Okay, subtract 24. Subtract 24. No more colors, guys. We're sticking with orange. So -180 is less than 30r. All right, and we're going to, I forgot, we can't change the colors. and divide by 30. And we get -6 is less than r. That one seems a little weird, right? So we're going to bring the r to the left-hand side. We're going to switch it. So everything gets flipped over, right? So if it was like this, we're switching it to this, right? A less than is now a greater than. So the r, this bigger part of this inequality is going to follow the r. So it's going to be r is greater than -6. Okay, so r is greater than -6. We're going to go to -6 right here. And that's going to be an open circle. Yeah, that's good. It's going to be an open circle because it cannot equal -6, right? Just like our domain and range, remember? And we're going to, it says r is greater than that. So what are all the numbers that are greater? It goes to the right. Okay, so it's going to be all of those guys. And that's how we graph it. Right. So 22 is going to have parentheses right here. So again, we're going to just distribute. So it's going to be -7 times -1 is going to be 7. -7 times -8 is going to be positive 56x. And we're going to copy the rest of it down. So +6 is less than or equal or greater than or equal to -267. All right, we got some like terms here on the left-hand side. So we're going to 56x, 7 plus 6 is going to be 13. It's greater than or equal to -267. Notice right here, I just put the variable first. You can do that, right? Because when we're adding, doesn't matter. And then we're gonna, again, two-step equation. So we have our -13 or -13 on both sides. And we have 56x is greater than or equal to -280. And we're gonna divide both sides by 56. And that's going to be x is greater than or equal to -1, 2, 3, 4, 5. I'm going to say 5. Let's find out. So that's going to be 280 divided by 56. Oh, can you see? I don't think you can see. Oh, but it's a 5 there. All right, so x is going to be greater than or equal to -5. So we go to -5. Here's -6, -4. -5 is halfway in between. So -5, and we're going to go greater than. So this way to the right is greater than, bigger numbers. All right, so those are, we're saying that these are all the solutions. So x could be -5, -4, -3, -2.6, right? Any of those numbers are going to work in this situation. Okay, so there's many, many numbers that will work. Whereas in equations, we only had one possibility. That's when we have an infinitely many different curves. Okay. Again, we have parentheses, so we're going to deal with that. We're going to distribute. If we didn't have parentheses, we wouldn't have to distribute. So -5 times 1 is -5. -5 times 2p is -10p is greater than -85. So I'm going to get rid of this -5 by adding 5. -10p is going to be greater than or equal to -80. And here we're divided by -10. Remember, when we're dividing by -10, that negative, like, throw things off, right? So when we're dividing by a negative, we do have to flip the inequality. So this is going to be less than or equal to 8. And this is why. Okay, so always just choose numbers that you work with. Okay, math is always logical. It should always make sense, right? So again, so if we say 2 is less than 2 is greater than 1. Is this true? Yes, this is true. Numbers that you know. Okay, 2 is bigger than 1. Yes, everybody knows that, right? If I were to add 3 to both sides, right, what would happen? 2 plus 3 is 5, is greater than 1 plus 3, which is 4. Is 5 greater than 4? Yep, see how it's still true, right? And if I were to subtract 3, we'd go back to 5 minus 3, which is 2, is greater than 4 minus 3, which is 1. Same thing, right? We're nothing. If I'm subtracting the same number on both sides, the inequality still remains true. Now, if I'm multiplying, so multiply by 3 on both sides. I'm just using 3 because I don't know. I just am. So 3 times 2 is 6, is greater than 1 times 3, which is 3. 6 is greater than 3? Yes, this is correct. Now, here we go. What if instead of, okay, come on, color. Really? The colors are not going to work. So what if we were going to multiply by -3 instead? How does that change? So that would just become -6, and that would be -3, right? Is -6 greater than -3? No, because if you're going to look at the number line, right? -6 is right here, right? -3 is higher, right? This is no longer true, right? This is no longer true, which means we actually have to flip the inequality. So -6 is less than -3. So whenever we're multiplying or dividing by a negative number, that does change the inequality. So we have to flip. That's why we have to flip the inequality. Okay, and so since we divided by -10, we did flip the inequality. So now it is a less than instead of a greater than. All right. Again, don't just try to memorize it. I would logically reason that out. So on the test, we'd be like, oh, do I flip it? And I would try some numbers when you multiply. You don't have to go through this whole process, just do the multiplication, right? Okay, so number 24, you have 90 is less than or equal to -6 times x, which is -6x. -6 times -7 is +42. And we're going to not change colors. So we're subtracting 42 on both sides. And so that's going to be 48 is less than or equal to -6x. And I'm dividing both sides by -6. That is the coefficient of x. Remember, I just divided by negative, so I am going to have to 6 times. So 48 divided by -6 is -8. I had to flip the inequality. So divided by negative. There we go. Okay, again, it doesn't matter if our answer was negative, right? If we're dividing by a negative, that's when we flip it. And again, I'm going to say this again. I'm going to flip the whole thing, right? So the x is now going to be on the left, which means that inequality, that smaller side, is going to follow the x. Right? So x is less than or equal to -8. We're going to go over here to -8. It is less than or equal to, so we're going to go to the left. It's less than. All right, there we go, done. Okay, we're going to go to the next group of 4, and these ones are compound inequalities. And what we're going to do here is we're going to solve for them in graphic. All right, so I'm going to just copy this down. There's not a lot of room right there. So again, if you look at this inside right here, right, we're going to solve for this b, okay? And what we would normally do, we would just add 8 to both sides, right? So add 8 here, add 8 to the right. But no, again, we have 2 inequalities, so we actually have 3 sides, right? So sometimes people like to, I really want to change colors. You know what, this is what we'll do. Go like this. There we go. So we can put like a line here, and line here, so it kind of reminds us where the 3 sides are. Sometimes it can be confusing. And we would get -4 plus 8 is 4, is less than or equal to, this cancels out, so we get -4b is less than 8. All right, and we're almost done with solving that. We're going to, so normally we would just divide by -4, but now we're going to do it to 2 other sides. By -4. Remember, when I'm dividing by a negative, what happens to those inequalities? It flips, right? So this is going to be -1. Now, instead of being less than, it's going to be greater than or equal to b, which is greater than -2. So -1 is greater than or equal to b, which is greater than -2. So here's -1. It is closed because it has an equal sign. We have -2. We know b is somewhere in between that. That looks weird. Here we go. So it's going to look something like that. Kind of like a musical note, but not. Because you would never have an open circle for a musical note or an eighth note, right? So it's going to be anywhere between -2 and 1, -1. That's going to be our solution. It's a very small window there, right? -1.5, -1.9. Cannot be -2 because it's open circle. Right? So anything in there. All right, let's try this again. -74 is less than 8b minus 2, which is less than 58, -58. All right, and we're going to add 2 to both or all 3 sides. And if you want to do your dotted lines, you can kind of see better where your sides are. You totally can do that. There we go. -74 plus 2 is -72, is less than 8b, which is less than -56. All right, and we're going to now divide by 8, all 3 sides. I'm dividing by a positive number, so I don't have to flip it. No flipping of the inequality. And then we get -9 is less than b, which is less than -7. All right, so we've got 9, and it's open circle for both. So -9, we got -7. We know that it's somewhere in between. So do you see how b is literally in between -9 and -7? That's what it's going to be. Notice these are called ands. So there are 2 kinds. We have and then we have ors. Ors look like this. Ands look like this 99% of the time. There are certain situations where it's not. And here we're just going to see ands being like this and ors being like that. Just saying. All right. In general, that is how it looks. Okay, so here's our solution here. Oh, it's a weird line. The box is apparently. All right, and we're going to go on to the next ones right here. Oh, do you see how these are ors? Right? Those are different. So here we go. -9 is less than 9 minus 9v. A lot of 9s going on. Less than 27. So here again, here's our left side, here's our right side, and our middle's right here. We're going to subtract 9 because we have a positive 9 here that we need to get rid of. These are just 2-step equations, peoples. And what do we have? 9 minus 9 is 0, is less than -9b, which is less than 18. You notice, just because it's 0 doesn't mean it just disappears. Okay, because a lot of people are like, oh, that's nothing, cancels out. We don't have the inequality anymore. That is, you can't do that. It doesn't just disappear like that. Now we're going to divide by -9, all 3 sides. Start with 3 sides, you're going to end up with 3 sides. That's how it should be. 0 divided by -9 is still 0, is less than, ooh, see that? You see my mistake. Where I divided by a negative number, which means I have to flip the inequality. So 0 is going to be my bigger number. And v is greater than -2. 0 is greater than -2, see? So we're going to go to -2. It is open. 0, it is open. And we know that v is somewhere in between. There we go. Done. And the last part, that last one of these ands, and the x minus 5 less than or equal to 19. Okay. Same deal. We're back to not being able to change colors again. There we go. We'll just do it all in one color. Add 5 to both all 3 sides. And we have 21 is less than or equal to 3x, which is less than or equal to 24. All right, and we're going to divide by 3 on all 3 sides. What do we have? 7. We're not flipping the inequality because it's a positive 3. So 7 is going to be our smaller number, right? Is less than or equal to x, which is less than or equal to 8. So we got 7, close circle, 8, close circle, anything. Oh, literally anything in between that will work. 7.1, 7.2. All the other numbers are not going to work for this situation. All right? Okay, now we're going to go to the ors. So do you see how this one literally has an or there? Yes, this is what we're doing. These ones, we consider them to be ands, right? Because it's going to be -2, and it's in between -2 and 0. Not -2 or 0. Different. Okay. So these are literally just two inequalities, two separate inequalities. We're going to treat them separately. Okay, so we have our first one here. So we have 4 plus 2v is greater than or equal to 8. And we're going to just solve it like how we normally would. So subtract 4 on both sides. We have 2v is greater than or equal to 4. And divide by 2. So v is greater than or equal to 2. That's the first one. All right. And then our second part, oh, we got our colors back. -3v minus 2 is greater than 1. So again, we're going to add 2 to both sides. And -3v is greater than 3. Divided by -3. Oh, remember, we're dividing by negative, which means we're going to have to flip that. V is less than -1. So now do we see how we have our two inequalities? Don't forget to put or, because we have both conditions, okay? It's either the purple condition or the orange condition, right? So if we're going to graph the purple one, v is greater than or equal to 2. At 2, it's going to be solid. It's going to be solid. It's going to be a closed circle. We're going to go to the right. And then for v is less than -1, it's going to be an open circle at -1, cannot equal -1, but it can go to the left. Anything to the left, anything less than -1. So all we're saying is that if either one of these two conditions are true, we're good to go. Okay. They cannot obviously both be true, because what number can you find that's less than -1 and greater than 2? You're not going to find one, right? But if one of those two conditions are true, then we're good. We're good. So we could not pick numbers like 0 or 1, because that satisfies none of those conditions. We can't have that. Okay. So there we go. So this is going to be our answer. You need to have both, and you have to put an or in between. That or does not just go away. All right, so here we go. Let's try the second one right here. So number 30, 10 plus 8x is less than or equal to -54. All right, again, we're going to subtract 10 on both sides. 8x is less than or equal to -64 divided by 8. We've got x is less than or equal to -8. That's our first part. So we've got -8 right here, less than. Okay, then we're going to do our second part. Remember, there was that or here, so we're going to put an or right there. -8 plus, -x plus 8 is less than or equal to 8. Subtract 8 on both sides. -x is less than or equal to 0. Dividing by -1. That's how you get rid of just the negative, right? We got x, remember we divided by negative, so it's x is greater than or equal to 0. This is our answer with our or. We're going to go over to 0. It is going to be a closed circle right there, because it can be equal to. I told you ors look like this, ands look like this. So again, if you're looking, see the one that says or, it's going out. The one, it doesn't say and, but it has these two conditions right here and just one x. That goes like this. Okay, so this is the kind of graph that you're going to see. Okay, and our last two of these kinds. Again, please practice these. All right, so I'm going to just copy this down. 3 minus 4x is less than or equal to -1. And subtract 3 on both sides. Don't know why, go to those previous problems, right? Problems 5 through whatever it was. -1 minus 3 is -4. Divide by -4. So we're going to have x is greater than or equal to +1. Don't forget to flip the inequality because we divided by negative. Oh, we're not done yet. Just make room. Since I already started. Put that or right. Okay, so here is, oh, yeah, we should graph that. x is greater than or equal to negative or positive 1. So closed circle going to the right. All right, we have 7 minus x is greater than or equal to 14. So we're going to subtract 7 on both sides. Negative x is greater than or equal to 7. And divide by negative 1 because we got to get rid of that negative. So x is, instead of greater than, is less than or equal to negative 7. Did you think I was going to forget that negative? All right, so here we go. At negative 7, it is going to be closed circle because it is equal to. There we go. Done. Last one of these problems, 6a plus 10 is greater than 34. We're going to subtract 10 on both sides. 6a is greater than 24. Okay, subtracting. Divided by 6, and we get a is greater than 4. So we're going to go to 4, greater than, so it's open circle going to the right. All those numbers are bigger than. And then 10a minus 1. A lot of people, the mistake is they just do one of them. They don't do both of them. And they're like, oh, or it's like a choice. Like you can decide which one to do first. No, you can decide which one to do first, but you have to do both. And then, so we're going to add 1 to both sides. 10a is less than negative 70. Divide by 10 on both sides. And we got a is less than negative 7. We're not flipping the inequality just because this answer is negative, right? We did not divide by a negative, so we just leave it. Don't forget our or. All right, so we're going to go all the way to negative 7. It is an open circle and going to the left. Sorry for that squiggle. There we go. Now we're going to sketch some lines here. Number 33. So graphing, this is in slope-intercept form. So this is going to be our y-intercept right here. Remember, it is y equals mx plus, mx plus b. And this is, remember, our plus b, our number that's by itself, is our slope. That's our slope, oh my goodness. Is our y-intercept? You saw nothing. Our m is our slope. My goodness, totally getting ahead of myself. So our y-intercept is where it starts on the y-axis, and our slope is how tilted something is, whether it's positive or negative. And right here we have the number that's by itself. That's our plus 2. So we're always on the y-axis, guys. Here's our 2. And our slope, so this is going to be our slope right here. It's right over it. Slope will be orange. And notice there's no number in front of x. So if there's no number, remember there's that invisible 1. So 1x. So we're going to go up 1 and then to the right 1. Up 1 to the right 1. So this is our slope of 1. It is positive. So notice it is increasing. From left to right, it is getting bigger. All right, here we go. Let's try our best to draw this line. There we go. There's a line that represents y equals x plus 2. Done. Number 34. Again, we have this plus 1 right here. That's our y-intercept. We're starting on the y-axis. A lot of people switch from going to the y-axis to the x-axis. Don't do that. It's called the y-intercept. You know why? Because it crosses the y-axis. So we're at 1 right here, and then our slope is negative 2/5. So we're going to go up 2. So from the 1, we're going to go up 2 and then 5 to the left. The reason we go 5 to the left is because it's negative. So we have to see how this is negative. It's descending, right? Negative slope. So 2 to the, or we can go 2 down, 5 to the right. And here we go. I always like to do at least 3 points on here just because it helps me to make a straighter line. But on the computer, I need to actually do all the points to help me make straighter-ish lines. Please use a ruler for you. A straight edge would be great. All right, 2 more of these types of problems. Our y-intercept is the 4. So we're going to go to positive 4. There's our y-intercept. And then our this is going to be slope of 2. Remember, think of 2 over 1, right? So it's going to be up 2 and to the right 1. So it's always rise over run. So it's the how much we go up, then we go over. Or we could go down 2 and then 1 to the left. Okay, I'm going to continue to do that so I can make a straight-ish line. All right, there we go. This is what we've been doing for like over half the year, right? So here it is, our increasing slope. On the number 36, we have +1. Oh, are these all positive? They're all positive. If this was a -1, we would go to the -1 right here. Okay, but since it's a +1, should have thought that one better. But oh well, we'll have more graphing situations later on. So at 1, and our slope is -1/3, so we know it's going to go down, right? It's going to be decreasing. So it's going to be 1 over 3. So we're going to go up 1 and then 3 to the left, right? This will ensure that it's decreasing instead of increasing. So 1 down, 3 to the right, just like that. It is a more gentle slope than the 2, right? Because we have a 1/3 slope, and this is 2, 2, so up 2 and over 1. Here we go. Done. Finished with all the graphs. So now we're going to solve systems. In this case, we're going to do that by either using substitution or elimination. One, you can use either method, but usually one method is a little easier depending on the situation. So if you notice right here, we have, well, let's use blue. They're both in slope-intercept form, y equals. We want to know where do they intersect, right? Where is that solution where the x and y work for both equations? Okay, and so instead of just trying different numbers for x and seeing if it gets the same y, we're actually going to just solve this algebraically so we can not have to try so hard, right? So we know that y is equal to both of them, so I can set these two equal to each other. So -8x minus 19 has to equal 6x plus 9. The reason why we know that is because they're both equal to the same thing, which is y. We don't know what it is because we don't know what y is, right? But we know that they are both equal to it, so which means they're equal to each other. Okay, so now we have just one equation with one variable. We've done this before, right? Variable on each side, but it's the same variable. Yeah, this is why we needed that stuff, right? So now we're going to subtract 6x on both sides. And we get negative 14x. I said negative 14 and I wrote 8. Negative 14x minus 19 is equal to 9. All right, and then we're going to just add 19 to both sides. And we have negative 14x is equal to 28. Divide by negative 14. Remember, we've been doing this, right? Just keep on practicing. It always comes up again and again. X is equal to -2. And most people will be like, oh yeah, we're done. Normally we would be done, but we're not, because remember, we're solving for system of equations, right? So we know what the x value is. Now we just need to plug it into one of these two equations to get the y value. So I'm going to go with this bottom one because they're all positives. Seems easier to me. You can totally do it with the top one because it will work for both. So 6 instead of x, what are we going to put in? We're going to put in we know what x is. X is -2. And then we're going to continue plus 9. So notice exactly the same. So when we got to x, we replaced it with -2 because we know that x is equal to -2. Because we want to know what y is if x is equal to -2. So y is equal to -12 plus 9. Y is equal to -2 plus -12 plus 9, which is -3. So our solution is going to be -2, comma, -3. Don't forget to add in your parentheses around there. That shows that it's an ordered pair, which means it's a point as opposed to two different answers, right? So -2, -3. So these two lines are going to cross right at -2, -3. All right, we're going to move on to the next one. Again, if you want to graph it, you can see it crosses right there. There we go. So negative 3x minus 1 is equal to negative 7x minus 1. So in this case, substitution is much easier because you can just set up the equation. We've solved these kinds of equations before, right? So negative 3x minus 1 is equal to negative 7x minus 1, right? Why? Because they're both equal to y. All right, we're just going to solve this right here. I'm going to add 7x to both sides. Again, if you want to add 3x to both sides, you are totally free to do that. You will get the same answer. Just the steps will look a little bit different. Okay, and then we get, we're going to get rid of this minus 1 by adding 1. And we get 4x is equal to negative 1 plus 1 is 0. All right, and I know that the only x, the number that x can be is 0. But we're just going to show it algebraically here. So you know that x is equal to 0. Now we're going to plug it in. I'm going to plug it into the top one because that is slightly smaller numbers, right? So I'm going to be like y is equal to negative 3. And some that we know is going to be 0 for x, and minus 1. So I'm going to plug in that 0 for x. And just let's see right there. That's where it is. That's where it came from, in case you didn't see it. So y is equal to, what is negative 3 times 0? 0. Minus 1. The 0 minus 1? Negative 1. All right, so then I know that my solution is going to be 0, comma, negative 1. So we know it's those two lines are going to cross at 0, negative 1, right? Right here, 0, negative 1. And we can do that all without having to graph it. I mean, these are not too bad to graph, but if they were bigger numbers like this guy right here, like number 37, that'd have been a little bit of a pain. Here we're going to practice these again, right? Okay, if you look at number 39, you can actually solve it by elimination. The reason why I know that is because notice the form is exactly the same, but this is 3x minus 3x. So you could cancel them out. It does work. And what's y plus y? That's 2y equals 14, right? 10 plus 4 is 14. And then you're just going to divide both sides by 2. You see, you can totally use elimination. It just depends on what the situation is, right? 14 divided by 2 is going to be 7. Okay, let me just show you. Oh, and then we'll figure out what our x is. And our x, now we know our y. We're going to figure out our x, and we're going to use, let's use the top one. Okay, so we know what y is. Y is 7 equals 3x plus 10. And now we're just going to solve for y. We're just going to subtract y on 10 on both sides. We get negative 3 is equal to negative, oh, no, just kidding, 3x. And then divide by 3. And we get negative 1 is equal to x. So our solution will be negative 1, 7. Forget the parentheses because you're showing that it's a point. Again, let me just show you, yes, you could definitely do it with the other way, the substitution. We would normally go 3x plus 10 is equal to negative 3x plus 4, right? This is how we've been setting it up. And again, we would have just added 3x to both sides. You'll see that the answer is the same. Just different methods. So 6x plus 10 is equal to 4. I'm going to subtract 10 on both sides. We got 6x is equal to negative 6. Divide by 6 on both sides, and we get x is equal to negative 1. See, same thing. But which way is faster? In this case, our elimination was faster, right? And since we could eliminate the x's, we could just, so you don't always have to do it one specific way. The more the different ways you have, the faster you can solve things. You don't have to spend your time doing, the steps. Okay, here you can't really just cancel them out, so I'm just going to set it up the way we've been setting them up. So here we go. So this is going to be 6x plus 11 is equal to 3x plus 2. We can use elimination here, but you're going to have to think about how would you do that. You can do that, and you can see if your answer is the same as mine. Because as you can see, the answer will be the same. All right, we're going to subtract 3x on both sides. And we have 6x minus 3x is 3x plus 11 is equal to 2. And then we're going to subtract 11. And we get 3x is equal to negative 9. And we're going to divide both sides by 3. We got x is equal to negative 3. Now we're going to just figure out our y. I'm just going to use this down here. So this is going to be y is equal to 3. We know what x is, plus 2. So instead of x, we're going to plug in negative 3 because we want to know what y is if x is equal to negative 3. All right, and we get y is equal to 3 times negative 3 is negative 9 plus 2. So y is equal to negative 7. So our answer is going to be negative 3, negative 7. So this is where they intersect. They meet at just this one point at negative 3, negative 7. Right there. All right, so now looks a little different, right? We have one that's as this slope-intercept form. The other one is in standard form. What do we do here, right? So what we're going to do is we're going to use substitution. That's the easiest way to go. So if you notice right here, I see the standard form, negative 4x plus 8. Instead of y, what we're going to do is we're going to substitute in, right, what y is equal to. And what is y equals negative 8. So I need to finish that equation. So what is y equal to? Y is equal to 2x minus 4. So what we're going to do is instead of y, we're going to take out y, we're going to put 2x minus 4. The reason why we do that is so that we have just one variable now, and we know how to solve these. We've done this like a bazillion times, right? So instead of this y right here, we're just going to plug that in. Let's go right in there. Okay, now let's solve this. Okay, we have parentheses, so we're going to have to distribute. So we have this negative 4x. 8 times 2 is going to be plus 16x. 8 times 4 is going to be negative 32 is equal to negative 8. We have some like terms over here. Negative 4x plus 16x is 12x. Minus 32 is equal to negative 8. Now we're back to our two-step equations. So we're going to add 32 to both sides. And we have 12x is equal to 24. There we go. And divide by 12, divide by 12. We're going to get x is equal to 2. Okay, I'm going to use the top equation because I already know that it's already solved for y, right? So it's less work for me. So y is equal to 2. We know what x is. It's going to be 2 minus 4. I'm just going to plug in this 2 right here. There. So instead of x, we got 2. And we're going to just solve for this. So y is equal to 2 times 2, which is 4, minus 4. 4 minus 4 is 0. So we know y is just equal to 0. So we have x is 2, y is 0. I'm going to just make it a little bit better. 2, 0. Right at 2, 0, that's where they intersect. Okay, so let's try this out. Same thing. So this time our bottom equation has the y equals, it's in slope-intercept form. We're going to just plug it into there. So we're going to just copy everything else down. So negative 2x minus 5. This is where our y is going to go, is equal to 2. So our y is going to be negative 2x minus 2. Ooh, that's weird. Minus 2. There we go. And we are going to just distribute. So we have negative 2x. Negative 5 times negative 2x is plus 10x. Negative 2 times negative 2 is plus 10 is equal to 2. I don't know why my equals is so high, but don't mind that. Negative 2x plus 10x is 8x plus 10 is equal to 2. And we're going to subtract 10 on both sides. 8x is equal to negative 8. Divide by 8, and you get x is equal to negative 4. Okay, we can use either equation, but honestly, the easier equation is going to be the one that's already has y equals solve for, right? So y is equal to negative 2. We're going to put our x there, and then minus 2. So our x we know is negative 1. So what is y going to be when x equal to negative 1? Well, let's see here. Negative 2 times negative 1 is 2, minus 2. Ooh, look. And I like the same thing. 2 minus 2 is 0. So we know we're going to have our y is 0. Our x is negative 1. So they're kind of like neighbors almost. All right. Again, we're going to practice those 2 more times. You practice some more. Just because you know it one time doesn't mean you're going to know it the second time, because the situation might be a little bit different, right? So the more you practice, the more you will see different situations, different scenarios, and you're like, oh, wait, I've done this scenario before. So that's why we keep on practicing. We don't just, it's not one and done. We keep on practicing again and again. All right, we're going on. Negative 2x plus 5. Instead of y, we're going to put 3x plus 16 here equals to negative 24. And here we go. Let's highlight this right here. It goes right here for this y. Probably should make that color opposite. So you won't be able to see it. So 3x plus 16 is right here. So negative 2x, we're going to distribute. 5 times 3 is going to be 15x plus 5 times 16, which is going to be 80, is equal to negative 24. We got some like terms here, so it's 13x plus 80 is equal to negative 24. See, two-step equation. Subtract 80 on both sides. 13x is equal to negative 104. We are going to divide by 13, and x is equal to negative something. Probably 9, 8. I want to say 8. Okay, just in case, right? Because this is going to make a difference. So 104 divided by 13, and that's going to be, yep, negative 8. There we go. And we're going to sub it in. We're going to use this top equation right here. So y is equal to 3 times plus 16. We're going to put a negative 8 right there. So that's going to be y is equal to 3 times negative 8, which is negative 24, plus 16. Y is equal to negative 4, negative 8. Ooh, negative 8, negative 8. X is negative 8, y is negative 8. Right there, done. All right, sure, moving on. 44. Negative x minus, oh, y is right here. This will be an interesting one. See, different situation. And instead of this y, we're going to plug in 5x minus 6. You guys might be confused here because we have not seen something exactly like this, right? We got our negative x. Remember, this is like our negative 1. We're going to just distribute the negative with a minus, if you want to think about it that way. So negative times 5x is going to be minus 5x. Negative times negative 6 is going to be plus 6. See how it goes? Just like that. Numbers haven't changed because we're just multiplying by a negative. All right, combined like terms, we've got negative 6x plus 6 is equal to negative 6. A lot of 6's going on. Subtract 6. Negative 6x is equal to negative 12. Divide by negative 6, and we have x is equal to 2. I'm going to just plug it into this top equation. Y is equal to 5. There's our x minus 6. Our x is 2. So we're going to have y is equal to 10x minus 6. Y is equal to 4. Again, our solution is going to be 2, 4. That's where they meet. Done. All right, so now we're going to work on the next 4 types of problems. And notice right here, nothing is solved for x. They're only in standard form. So while you can change, like solve this for y, like the top equation for y, and then plug it in, like we've been doing. But here, usually we use elimination. It's a lot simpler. And yeah, a little less work, less steps in general. So notice that I cannot cancel anything out. So what I'm going to do is I'm going to use either, think about if I want to cancel out the x's or the y's. I noticed that the 4 and the 12, if I multiply this 4 with 3, then I could get this to be 12, right? And I could cancel it out. So that's what I'm going to do. I'm going to multiply everything with 3. So the top is going to stay the same because I'm not doing anything to the top. So I'm going to just copy that down. And then the bottom, so 3 times negative 4x is negative 12x. 3 times 9 is going to be minus 27. y is equal to 3 times 0, which is 0. Okay? We get to multiply that last number as well. And so this is called elimination for a reason, because we're going to eliminate the variable. So we just eliminated the x's. Now we just have the y's, and we know how to solve that, right? So negative y minus 27 is negative 28y is equal to 0 plus 0 is 0. Divide both sides by negative 28, and y is equal to 0. Now we're going to substitute it in. Let's sub it in for the top one. Looks maybe it could be a little bit easier. We'll see. So 12x minus equals 0. So we know that this y is going to be 0. Well, I know what 12x minus 0 is, right? It's just 12x. 12x is equal to 0. I think I know what the answer is. X is equal to 0. So we have 0, 0. It crosses right at the origin. Nothing that interesting, but at least we know, right? 0, 0. So don't get freaked out when you see zeros. It is still a solution. We still could get an answer. All right, if you look right here, I noticed that the y's look a little bit simpler to multiply to get to be the same, right? And I see that the top is 2. And if I multiply this by another 2, that could give me a 4, right? So I'm going to multiply the top equation by 2. I'm doubling everything. Okay, so I'm going to get negative 16x. 2 times 2 is going to be 4, so plus 4y. 2 times 3, it's 30, is going to be 60. Right, don't forget to multiply. That's where a lot of people get in trouble. They don't do that. And the bottom equation, we're going to just leave as is, just like this. So 28. Cancel that out, and we get negative, what is this? Negative 22x is equal to 88. Ooh, what's it going to be? Divided by negative 22. X is equal to negative 4. All right, I'm going to plug that into the bottom one. Honestly, it doesn't really matter because it's going to be the same difficulty level. So negative 6, instead of x, we're going to put a negative 4. Minus 4y is equal to 28. I'm just going to plug in my negative 4 in for the x. Let's solve this. So this is going to be 28 minus 4y is equal to 28. Subtract 28, subtract 28. Negative 4y is equal to 0. We know that that's just a number. We're dividing by negative 4. Y is equal to 0. So our answer is going to be negative 4, 0. Right? 0 is still a number. People like to freak out on those ones. All right, the last two problems of this type. Okay, let me just show you. There is an easier way by just eliminating the x's, or you can eliminate the y's. And let me just show you just so that you can see it, that you've seen it before. So the way we can eliminate the y's is you think of what number does 2 and 5 both go into? And I always take 5. Does 2 go into 5 evenly? No. So I double that. So 5 times 2, so that'll be 10. Does 2 go into 10? Yes. So that's the number I want both of these y's to be, or both of the coefficients of the y's to be. I'm going to multiply the top one by 2. And what I'm going to multiply the bottom one by negative 5, right? Because negative 5 times 2 will give me that negative, so I can cancel them out, right? There we go. So 2 times, that'll be 11 is 22x. 2 times 5y is plus 10y, equal to 2 times negative 23 is going to be negative 46. Right, I know it would be easier if we just multiply the bottom by negative 11. You could totally do that and cancel out the x's. I'm just showing you this other way, just so that you can see it. Negative 5 times x, not that you haven't seen it before. We learned this before earlier in the year. That's why it's on the final. Negative 5 times 2y is going to be negative 10y. See how now we could cancel it out? Equals to negative 5 times negative 16 is going to be positive 80. It cancels out, and we get, that's going to be 17x is equal to 30. 34. All right, divide by 17. Divided by 17, x is equal to 2. Done. All right, I'm going to use this bottom equation because that looks a bit simpler. So x, oh, we know what x is, right? I'm going to leave some space there. Plus 2y is equal to negative 16. And I'm going to plug in that 2 for our x, just like that. So now I'm going to subtract 2 on both sides. We get 2y is equal to negative 18. Divide by 2. So y is equal to negative 9. So we got 2, negative 9 as our answer. Don't forget to write it as a point. Our last one for this set. Okay, I'm going to cancel out the y's because I can see that 9 times 2 would give me that 18. I'm just going to multiply the bottom by 2, not just 2, but a negative 2. Because since they're both minuses, I want them, like, they need to be opposite, right? So they can cancel out. All right, so I'm going to just copy down the top part. 4x minus 18y is equal to negative 30. And we got 2 times negative 9 is negative 18x plus 18y is equal to 2 times 27 is negative 54. Y's cancel out, and we get, what do we have left? We have negative 14x is equal to negative 84. We divide by negative 14. Negative 14. X is equal to positive 6. Just in case, because I don't want to like make a mistake, because that's going to cost me some time here. Yep, correct, 6. And we're going to plug it in. Where should we plug it in? To the bottom one? Let's do the bottom one. I don't really want to write it. So let's do the bottom one. So we got 9x. Oh, wait. I mean, this. So I'm going to just, there we go, for x minus 9y is equal to 27. We're putting in our 6 right in for our x. Let's solve this. It's going to be 54 minus 9y is equal to 27. Subtract 54. We got negative 9y is equal to negative 27. Divided by negative 9. No, y is equal to 3. So our answer is going to be 6, 3. Done. All right, the third way that we can solve these system of equations is by graphing. I should have done this first, but that's fine. That's what it is. All right, so we know how to graph these because we've done these before. So again, we're going to just basically just putting 2 graphs on one, right? 2 lines on one. We're starting at negative 3. I told you we would count negatives. And our slope is negative 1/3. So we're going to go up 1 and to the left 3 because it is a negative slope. And so it should be descending, decreasing. Okay. Imagine that it went through all the points, okay? And then our second one is going to be our plus 2. It starts again at 2, always on the y-axis, and our slope is negative 2. We're going to go up 2 and then to the left, or down 2 and to the right. And if you notice, you can see exactly where it crosses, right? Where they meet. Meet right here at, where's that? 3, negative 4. Done. Graphing is great if you have smaller numbers. The big numbers, that's not going to be as nice. All right, we'll try this again. So we're going to start at negative 3. So on the y-axis, negative 3. Slope is 1/2 positive, so it's up 1 to the right 2. Up 1 to the right 2. All right, we're going to just cross this. In Algebra 1, we're just going to have them cross right at a nice point. So one of these points is going to be the solution. It's telling you right now, right? So just a little hit, right? Is it always like that in real life? No. But in Algebra 1, since we're just kind of working on it, we're beginners a little bit, still it's going to be like that. So here's 4. And this is going to be our slope. I can't go up 4, so I'm going to have to go down 4. Since it's positive, if I go to the right, see how I'm decreasing? I don't want that. So I got to go to the left because I want, it's a positive 4, it should be increasing. Oh, see? Do you see where it's going to intersect? right there. So that's going to be at -2, -4. There we go. There's our intersection right there. All right. Moving on to 51. Okay, we're starting at -3. So on our y-axis, -3. Our slope is -1/4. So up 1 to the left 4. Or down 1 to the right 4. Draw that line, just like that. Then the second equation is going to be +1. So on our y-axis is 1. We're going to go, I can't go up 5, so I'm going to go down 5. There's 4, 5. And then we're decreasing, so I have to go to the right. Oh, look, you know exactly where they cross. Right there. So that's going to be 4, -4. Oh, did you notice that all of our answers have been like the y coordinate is -4? That was not planned, people. I did not plan that. That is so interesting. I wonder if this one is like that too. No. Something was telling me to do that. Okay, this is 2, and then we're going to go up 3 and to the left 2 because it's negative. Down 3 to the right 2. There we go. Draw our line. One of these 4 points is our solution. And then here is our -3, so we're going to go down to -3. Our slope, if remember, if there's no number there, it's a slope of 1, so we know that up 1 over 1, up 1 to the right 1, because it is a positive slope. There we go, and intersects right here. Ooh, we broke the pattern. It's 2, -1. You just look for where they intersect. So instead of solving this algebraically, because dealing with fractions is kind of a pain, if we do it graphically, you can just figure out where they intersect, and that's your solution. All right, this one is when we have them both in standard form. There are 2 ways to do this. You can either graph them by intercepts. Like this first one is a nice one to do with intercepts, and the second one we're going to change to slope-intercept. So that would just be easy. So if you look at right here, the way we solve with intercepts is if x is equal to 0, what is y going to be? This is our y-intercept here. So if x is equal to 0, that's 0, right? That would be 0. It's weird 0. That's 0. That's 0 plus 2y, so it's 2y is equal to -8. So I'm going to just solve for this. Divide by 2, so the y would equal to -4. So if x is 0, y is equal to -4. Right there. Okay, we're going to do the same thing. This is solving by intercepts as y equals to 0, right? Let me do this with a different color. Let me do it with blue. So if y is equal to 0, right, that means 2 times 0 is 0. And what do we get? This is y equals to 0. That means x is equal to -8. Okay, so we just get this x equals to -8. And we're going to go right here, -8 on the x-axis. That's our x-intercept. All right, and then you can see we're going to just draw that line there. I want to make sure that I get the right points here, so let me use a different color here. So I'm going up 4 and to the left 8, so I'm going to go down 4 to the right 8. So it looks like my slope is like -1/2, -1/2 since I'm going down. I'm just going to kind of fill these in because normally I would use a ruler, but I can't use a ruler on here, so I need to be a little more accurate so I know what my answer is going to be. Okay, there we go. But on the second one, we cannot find intercepts because they're not going to be as nice. Because 5 does not go into 9. So I'm gonna just solve, change this to slope-intercept form. So again, we're gonna subtract 5x on both sides. We want to solve for y here. We get 3y is equal to -5x plus 9. And then we're going to divide everything by 3. Get y equals to -5/3. A lot of people freak out here because they're like, ooh, 3 doesn't go to 5 evenly. That's fine. We don't mind fractions. Or we've dealt with fractions before, right? 9 divided by 3 is 3. So again, our y-intercept is going to be at 3. And our slope is -5/3, so we're going to go up 5. 1, 2, 3, 4, 5, and then to the left 3. Right, or down 5, to the right 3. And 3, 4, 5 to the right. Oops, where it intersects right here. There we go. And so the intersection is right there at 6, -7. Okay, so you can always change the slope-intercept formula, it will always work. But if you want to use intercepts, you can do that too. On the top one I see right here, and the way you can figure out if you can use intercepts is if you take the 2, you just take the coefficient divided by this constant over here. If it divides in okay, you're fine. Like 10 does not go into 4, so we're just going to change it to slope-intercept form. So here we go. This is going to be 10x minus y is equal to -4. Let's subtract 10x. Negative y is equal to -10x minus 4. Get rid of that negative by dividing by -1. Y is equal to 10x plus 4. We're going to go to 4. Can't go up 10, so I'm going to go down 10. And then to the right one, or to the left one, because that's a positive. All right, and then we're going to use intercepts here, because I notice that 2 goes into -8. So if x is equal to 0, that's 0. So that means my y is equal to -8. Y is equal to -8 then. And if my y is equal to 0, I get 2x is equal to -8. And divide by 2, and I have x equal to -4. So x -4 when y is equal to 0. And we're going to just draw this line. Ooh. And see, I notice right here, it crosses right here at -1, -6. I'm just going to make sure I got this right. So my slope would be up 2 over 1, up 2 over 1, up 2 over 1, 2 over 1. Yes, I do end up at -4 on the x-axis, so we know we're good. That's going to be our solution. That's going to be -1, -6. Done. All right. Going on to the next. Oops. Too far. Number 55. Although 7 goes into 63 evenly, but x is going to be -63, and I cannot graph that. So I'm just going to be changing that to slope-intercept. So x plus 7y is equal to -63. Subtract x on both sides. We got 7y is equal to -x minus 63. Divide by 7. Just dividing everything by 7 so I don't have to distribute it out. So y is equal to, remember this is going to be a -1 there, so -1 over 7, x minus 9. 63 divided by 7 is 9. So now I can graph this. So I'm going to go down to -9 on the y-axis, and then up 1, and then to the left 7. Because it is negative. It's going to look something like this. There we go, going down. And then we're going to do the same thing with the second one. So we got 15x minus 7y is equal to -49. I'm going to subtract 15 on both sides, or 15x on both sides. Get -7y is equal to -15x minus 49. We're going to divide both sides by -7. And we're going to get y is equal to 15 over 7, whatever that may be. -49 divided by -7 is +7. I'm going to go up here to +7, and that's 15. I can't go 15 up, so I'm going to go 15 down. When 7 is 15, and then 7 across right here. That's the solution right there. So that's going to be -7, -8. Right, there's a solution. Don't forget, you don't just graph it because that's just the method to find your solution. Don't forget to write down the actual solution. Okay, we're going on to the next one. This top one, I'm going to just change it. 9x plus 2y is equal to -8. Subtract 9x. So 2y is equal to -9x minus 8. Divide by 2, everything divide by 2. Y is equal to -9 over 2x. 8 divided by 2 is -4. The y-axis, I'm at -4. And I'm going to go up 9. 4, 5. So here's 9. And then I'm going to go to the left 2 because I want that decreasing. So it's going to be just like that. And again, for my second one right here, this one I can actually solve by by intercepts. So if my x is equal to 0, right, that 0, I just get 2y is equal to 8, which means that y is, if I divide both sides by 2, y is equal to 4. So I'm going to be like y is equal to 4 when x is 0. There we go. That's my first intercept, or my y-intercept, I should say. And for my x-intercept is when y is equal to 0. If y is 0, that just means x is equal to 8. That was a weird 8. Okay, so 8 right here. Okay, do you see it? Where is it going to cross? Oh, not a straight line. Okay, it looks like it's crossing right there. Let me just verify it. I noticed that that slope is 1/2, -1/2. So I'm just going to go up 1, left 2, just to make sure that it all falls in line. Do you see how it like fits the line right there? Yep, solution's right in there with my slope, so it works out. So that's going to be -2, +5. There's my solution right there. All right, so we have now finished all the system of equations. Now we're going to do system of inequalities. And the only way we've solved this is through graphs. Okay, so we're close to being done. All right, we're going to graph it the exact same way. Okay, remember our -3 is our y-intercept. And our slope is going to be -2. So up to left 1, to left 1, all the way like this. And it is going to be a dashed line. Remember, if there's no equal to sign, there's a dashed line. Okay, at this juncture, we're just going to, it says y is greater than. Remember, this line basically cuts this y-axis, right? Where does it cross this right? Where does it cut this y-axis? Right here at -3. Right, so we have the y values on top, y values on the bottom. It says that the y values are greater than the line. So this is a line where the y values are bigger, so we know it's going to be shading on this side. All right, and of course you can always check your point, but I always found this to be easier for the y-intercept, or if it's in slope-intercept form. All right, second one is going to be y is greater than 4x plus 3. Here's my +3 right here. 4, I would go up 4, but I can't, so I'm going to go down 4. To the left 1, down forward 1. And this is also going to be dashed because it is not equal to. All right, and this is as y is greater than, so all the y's that are greater than are up top. So we're going to be above. So it has to be above the blue line and above the magenta line. So the only place that, only space that does that, only region that does that, it's right here. So this is the part that we shade. This fulfills both criteria for the intersect. All right, there we go. This is where we would shade. Okay, moving on. So here we're going to just graph this. -1 is my y-intercept. My slope is 2/3, so up 2, right 3, or down 2, left 3. It is going to be a solid line because there's that equal to sign right there. Ooh, a bad line. So make sure you're going all the way across. This y is greater than, so we know that it's going to be above this line. So I'm just going to do my arrows like this. And then right here, our second one, it says y is less than -3. My y-intercept is at -3. There is no slope, right? So if it's no slope, it's going to be going straight across like this. This is y. It is dotted line or dashed line because there's no equal to. So where are all the y values less than -3? It's going to be below this orange line. So if it's below the orange line but above the purple line, all we have left is this little space right here, little region. Technically, it's a lot bigger than that. If we were to zoom out, it'd be that whole this whole section right here, right? But we don't need to graph that part. It's just going to be this little part that we see. Okay, that's all going to be shaded. All right, moving on. We have here, let me just check. Okay, we got to practice 2 more times. Please practice this on your own. Will be ideal. So again, these are in slope-intercept form, so we're going to graph it just like how we've been graphing them. Slope is -1/2, so we're going to go up 1/2. This is going to be a dashed line because there's no equal to. It says y is greater than, which means it's going to be above the line. You know, it's going to be so somewhere up here we're going to be shading. Don't know where yet because we need the second line. So here, this is our +1. So right here at 1, our slope is -1. So we're going to be going up and to the left because it is negative. We're going down. We're descending, decreasing. Okay, and it is going to be a solid line because there's an equal to sign. It's going to make a dashed line. Okay. And it says y is greater than. We know it's greater than. It's going to be up top of here. So again, it's above the orange and above the blue, which means the only region that we can shade that's a solution is going to be up here. There we go. Done. All right. So number 60. Again, we're going to be graphing these guys. So this is at +1, +1. And their slope is -4. So up 4, 1, 2, 3, 4. The left one, because it's a negative slope, it's going to be a solid line because it has an equal to. And again, it says y is less than. So we're going to get all the y values that are less than, which is below the line. So we're going to go that way. We know somewhere over here we're going to be shading. Just don't know where yet. All right, second one is going to be -2. We're going to start here at -2. Our slope is -1. So up 1 to the left 1. So we're going just like this. It's going to be a dashed line. Nope, just kidding. I mean, a solid line because it's equal to. Okay. And it says y is greater than. And these are all the values that are greater than is above the line. So it's going to be up here. So below the orange, above the blue, the only place we can shade is right here in between. It's like that. There we go. We've solved those. Any point in here is what we call a solution. At any point will work for both of these two inequalities. All right, now we're going to do the same thing in standard form. Again, we can treat these, what you can do is if you're like, I want to just know one way, that's fine. Then you could always change this to slope-intercept form, okay? Or you can solve it by intercepts. Either way is fine. I'll show you both ways. The top one, I'm going to show you with slope-intercept, no, with, what is it called? Intercepts. Second one, I'm going to show you with, well, second one I'll show you with slope-intercept form. Sure. Okay, so here, if we're doing the first one right here, we're doing intercepts. X is equal to 0. If x is equal to 0, y is going to be 5. Right, so x is 0, y is 5 is right here. And we're going to be like, well, what if y is equal to 0? Again, these are our intercepts. We're looking for the extremes. Y is equal to 0, x is equal to 5. because 5 plus 0 is 5. I wrote down 0. There, x is equal to 5, and so we're going to be right here. Looks like we're going to be a slope of -1 right here. It is going to be solid because we have that equal sign underneath. So I am going to be like, this right. The reason why I knew it was going to be -1 is because we're going to the left, and my x and y intercepts are both at 5. My slope has to be, there'll be 5 over 5, right? Which is just 1. Okay, there we go. And in this case, we cannot use, it's greater than, because we have x and y both on the same side, so you can't do that. We have to actually check the point. So you're going to check the point, 0, 0. You can actually pick any point. I like to pick 0, 0 because it's easy to calculate with, right? So I'm going to plug it into, we're going to see if it's a solution. So 0 plus 0 is greater than or equal to 5. We don't know that's greater than or equal to 5, so we put a question mark. And we say 0 is greater than or equal to 5. That's true? No, it's not true. Not true, which means the solution, 0, 0 is not a solution, which means all the solutions are above here. So we know solutions, if it doesn't work on one side, all the solutions are on the other side. So there we go. Second one, let's try this out. Let's use this color. We're going to do, I'm going to change this to slope-intercept form. Actually, this one, I'll just do the intercepts like I said I was going to. Actually, I don't think I said that, but I'm changing my mind. If x is equal to 0, y is equal to 4y equals 8. Right? The reason why I could change this just to equal signs because we're looking for a specific instance. We're looking for the y-intercept, right? So that's what we're changing to equals for right now. So y is equal to 2, okay? So we know that y is equal to 2 if x is 0. And then for the y-intercept, or for the x-intercept, that's when y is equal to 0. That's the whole thing's going to be 0 because 4 times 0 is 0. Get x equal to 8. So x is equal to 8 right here. Then, so it looks like our slope is going to be 8 over 2, or 2 over 8. So it's 1/4. So it's going to, just like that. And this is going to be also a solid line. All right, just like that. Again, we're going to check our point. So we're going to check 0, 0. Because 0, 0 is not on the line. 0, 0 is on the line. You'd have to pick a different one, right? So if you pick 0, 0, 0 plus 4 times 0, is that equal to 8? And then that's just, the whole thing is just going to be 0. Is 0 less than or equal to 8? Yes, that is definitely true. So it works here. So we know that all the solutions are going to be below the sign. It's towards 0, 0. So where are we shading? The only place where that works, whereas above the maroon and below the purple, is this little spot. That's it. All we got. Okay. And then 62. Okay, I told you I was going to show you by using slope-intercept form. We totally can do that. So I'm going to copy this down. I'm going to, again, solve for y. So negative y is greater than negative x plus 4. Divide by -1. And y is less, and remember to flip it. By flip the inequality, we've learned this already. A negative divided by negative is positive. X minus 4. So we're going to start graphing this at -4. Slope is 1. So here, slope is 1. Oh, that's weird. It's going to be dot dashed. Okay, so it's a little bit more. So I know where I'm going. Okay, so here's my dashed line. Because y is less than, so we're going to go below. Okay, again, if you wanted to, again, if you were to check the solution, you could plug in 0, 0. 0 is less than -4. Is that true? 0 is not less than -4, so 0, 0 is not a solution. And you see how we're pointing on the other side. Whoops. A second. Excuse me. Did you say bless you? I'm just kidding. All right. Same thing with the second one over here. So x minus y is less than -3. So again, we're going to subtract x on both sides. Negative y is less than negative x minus 3. Divide by -1. Y is, remember, we're going to flip the inequality, so greater than x plus 3. So we're at 3, slope of 1. Ooh, this is interesting. It is going to be dashed. There we go. And it says y is greater than, so y is going to be above here. All right. Where do they intersect? Where do they meet? They don't, which means there is no solution here. There's nowhere where both of them work. So this one is actually just no solution. The first of these kind of things. So if they were to, if it was instead of greater than, if it was less than, then what the overlap would be over here in this purple area down here, right? Because it wouldn't be here because in between the lines, purple does not point to that. So it wouldn't be there. So there we go. We're going to try this again. 63. I'm going to change this to slope-intercept form because 3 does not go into 4 evenly. So 3x minus 2y is less than 4. Subtract 3x. We've got negative 2y is less than negative 3x plus 4. Divide by negative 2. Y is greater than 3 over 2x minus 2. So we have minus 2 right here. We're going to go up 3 to the right 2, up 3 to the right 2. And this is going to be dashed line down 3 to the left 2. Okay. And it says y is greater than, so which means that y is going to be above. There we go. And then second one, I'm not going to be able to graph negative 36 as an x-intercept. So I'm going to change this one as well. So x minus 6y is less than negative 36. So negative x, or subtract x on both sides. That negative 6y is less than negative x minus 36. Divide by negative 6 on both sides. We get y is, since I'm divided by negative, got to flip it. 1 over 6x plus 6. Because 36 divided by 6 is 6. And again, remember, this is not a slope of 6, it's a slope of 1 over 6, because 6 is on the denominator. It's on the bottom. All right, so our y-intercept is 6. Our slope is 1/6. 1 over 6. Ooh, look. That's where they intersect. A little bit. And this is also going to be dashed. Okay, this is a really dash. That's a bad dash line, but assume that it's straight. And again, y is greater than, so it's going to be above the line. So it's going to be above this one and above the orange. So it's got to be up to that orange line. Done. Okay, we're going to do the same thing on the second one right here. Yeah, 9 does not go into 56 evenly, so I'm changing this to slope-intercept form. Finding intercepts is doesn't occur too often, but it is useful to know how to do. 8y is less than or equal to negative 9x plus 56 divided by 8. Divided by 8. So y, I do not need to flip it because I did not divide by negative. Negative 9/8 x plus 7. I'm going to go to 7, and we're going to go 9/8. So I can't go up 9, so I'm going to go down 9. So that's 7, 8, 9. And then to the right is going to, and it's going to be a solid line, so it's going to look like that. All right, sorry about that weird line. And it says y is less than, so this way going down is less than. And we're going to go second one, 5x minus 8y is less than or equal to 56. This is also equal to 56. So subtract 5x. We get negative 8y is less than or equal to negative 5x plus 56. Sorry, can't see very well. Divide by negative 8. And y, again, flip the inequality because we're divided by negative. 5/8 x, 56 divided by negative 8 is negative 7. So I'm going to be here at negative 7. The big thing that people will get messed up on is the negatives in the flipping. That's going to make a difference. Make sure you're careful with that. And then we're going to go up 5, the right 8. This is also going to be a solid line because it's equal to. And y is greater than, so we know that y is going to be above the line, right? And the only word to see where it's all pointing to, we would get a big space this time. All of this. Oops, I didn't mean to go over there. Sorry about that. There we go. Good job, guys. We're almost there. All right. We're at simplifying exponents, exponent properties. We're going to focus on this one right here where we're multiplying. So we have, remember, m to the third power means, so we have this negative, and it means m times n, right? That's this guy right here. And what do we have here? We have another m times m, because that's what m to the third power means, right? So how many m's are we multiplying? That's 6. So we got negative m to the 6th power. So the shortcut way, if you can figure out in your brain, you could always write it out like this, always expand it, right? But you can just, in your brain, imagine you got 3 m's and another 3 m's that we're multiplying. So total, we have 6 m's. So we can just add those exponents up. Same thing here. We have negative 2 times 3. So it's going to be negative 6. And then we have 3 x's here and another 2 x's here that we're multiplying. So that's actually x to the 5th power, right, that we're multiplying. See, done. Here, negative 2 times negative 2 is positive 4. So we're going to multiply the coefficients. We have 3 x's here, and how many x's do we have here? We don't have any because it's 0, right? So we just have x to the 3rd power. Negative 3 times negative 4 is positive 12. We have n. There are 4 n's here, and then 2 more n's here. Okay, so that's actually 6 n's that we're multiplying. Okay, in your brain, you need to imagine all these m's and n's and whatever, all the variables multiplying with each other. Done. All right, simplify. We're going to use the factor tree to get our prime factorization. So what times what multiplies to 192? I'm not sure. I know this is an even number, so I'm going to be like 2. Right? 2 goes into 9 times, remainder 1. So you have 12, so 96. So 2 times 96, you could totally use your calculator, no problem. And we're going to keep on breaking it down until we get the prime numbers. If it was a prime number, it's the only even prime number. And break down the 96 so that I know 3 goes in there. So 3 times 32 goes into, so 3 times 32 is 96. So 3 is a prime number. I'm going to break down the 32. I know 8 times 4 is 32. I'm going to break down the 8. So we just keep on breaking them down until we can't break them down anymore. And then there's 2 over here. Oh, lots of stuff going on. So all I have are 2's and 3's left. So we know that the square root of 92 is the same thing as the square root of, how many 2's do I have? 1, 2, no, not this one. So 1, 2, 3, 4, 5, 6. 2 times 2 times 2 times 2 times 2 times 2. Then how many 3's do I have? Just have this 1 3 here. Yep, so times 3. Notice I'm not using the 8 because we split up the 8 with 4 and 2, right? We're not using this 4 because we split that up into 2 and 2. So you're only getting the prime numbers, right? Because we broke it down. So if we were to multiply this all up, 2 times 2 times 2 times 2 times 2 times 2 times 3, that equals to 192. Okay? Don't believe me? Try it. See, it's the same. Okay, so now I'm going to look for my perfect squares. And what perfect squares are like 2 times 2, that's 2 squared, perfect square. Times, I have this one right here, I have another one, right? 2 squared, and I have another one, 2 squared. And then I have this 3, that's not a perfect square, but I'm going to leave it, times 3. So the square root of 2 squared is what? 2, right? How do I know that? Because what is 2 squared? 4. What is the square root of 4? 2. See what I'm saying? No square roots anymore, right? Same thing happens to this one, same thing happens to this one. And what's the square root of 3? I don't know. So we're going to leave that as, it's not, 3 is not a perfect square, so we're going to leave it inside the square root, okay? And so we got 2 times 2 times 2, which we know is 8. Did you say 6? It's 8 root 3. So this is simplified now. So this looks a little bit simpler than this one up here, the smaller numbers. That's what we're looking for. We're going to do the same thing with this guy right here, 128. I know that 4 goes into 128 4 times. Let's see, 4 goes into 12 3 times. 4 goes into 8 2 times. There we go. And 4, I'm breaking it down to 2 and 2. 32, I'm breaking it down to 2 and 16. 16, I know, is 4 and 4. And 4 and 4 is 2 and 2, and 2 and 2. Done. So my prime factorization is just all 2s. Let's see how many. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. I need one more. 7. Done. All right, I'm looking for my perfect squares. Now, you may think to yourself, Miss Lee, there's a shortcut, and there is. But I'm not going to tell you. You're going to have to figure that out for yourself. Because if I tell you the shortcut, you're not going to know why. And you're going to be like, just random memorizing, right? You just brute. Yeah, no, we're not doing that. So 2 squares. So if you know what if you can see some shortcuts, do it. So we have our perfect squares right here. We have our perfect squares right there. Another perfect square right there. And then just the 2. All right. So we know that the square root of 2 squared is 4, and the square root of 4 is 2. So that happens for all of those perfect squares. And this 2 doesn't have a pair, right? So it's not a perfect square. Ooh, I'm right. So 2 times 2 times 2 is 8 root 2. There it is. Smaller numbers. All right, and we're going to go to the next one, 245. I know 5 goes in there. 5 goes into 245 49 times. Ooh, 49 is a perfect square. But 49 can be split up into 7 and 7. And 5s and 7s are all are all prime numbers. So I know that it's going to be 7 times 7. Honestly, the order doesn't matter, but I like to group up my pairs in the front. And then times 5. All right, this is my perfect square right here. So it's going to be 7 squared times 5. And what is 7 squared? 49. What is the square root of 49? 7. See, it always leads us back to the same number. So 7 root 5. So the square root of 245 is the same thing as 7 root 5, or 7 square root of 5. All right, now 196. I know 3 goes in there. And if you don't know, just use your calculator and just divide it by different numbers. Actually, 3 does not go in there. Just kidding. 4 goes in there. If you do 2, you can totally do 2. I'm going to do 4 because I know 4 goes in there evenly. 4 goes into 19 4 times, remainder of 3. 9 goes into 36 9 times. 4 goes into 36 9. All right, and then we got 4, which is 4. Just kidding. 2 and 2. Numbers 2 times 2, not 2 plus 2. And this is going to be 7 times 7. Ooh, this is going to be interesting. 2 times 2 times 7 times 7. I got a perfect square right here with the 2's. 2 squared. Got a perfect square with the 7's, times 7 squared. That's going to be 2 times 7, which is just 14. Notice no square root. Because guess what? 196 is actually a perfect square. Because 14 times 14 is 196. So that's what happens if you don't have any square roots. Or if you don't have any, no like leftover numbers. All right, we're going to find the product. Okay, so I showed you the area model. I'll show you the area model and then I'll show you the other way. And you can decide which way you want to do it. The only reason why I really like the area model is because, first of all, it's visual. And second of all, you won't forget all the steps. Because doing it the other way that I'm going to show you, you'll forget. Some people forget all the steps and they miss some stuff. So again, area model, this is the length of one of the sides. I'm just going to put it on the left. So this is 8x minus 5. Top part is 7x minus 3. Notice the minus is going with that second number there. Now, area means we're finding the area, which means that's multiplying the sides, right? So it's 8x times 7x, which is going to be 56x squared, because we have two x's that are multiplying together, right? Same thing with this one. This is 8x times negative 3, which is negative 24x. How come it's not squared? Because we only have one x that we're multiplying. Same thing on the bottom. That's going to be negative 5 times 7x is negative 35x. Negative 5 times negative 3 is positive 15. So now we're going to combine like terms here. We got 56x squared. Negative 35x minus 24x is going to be negative 59x. And then we got our plus 15. Done. So remember, we're combining like terms. So these two guys right here, we got to add them up together to get that right there. So those are like terms. Okay, so we always want it in the simplest form. We always start with the highest exponent first, and then the next highest, and then the constant at the end. Okay, like I said, actually for 73, I'll show you the other way so you can see the difference, okay? So you would just, it's just distributing. You're just distributing twice. First with the 8x. So 8x times 7x is what? 56x squared. 8x times negative 3 is going to be negative 24x. You see how it's like the same thing as that first line there? See. And then we're going to do the second part, which is going to be the negative 5. We're going to distribute that. The negative 5 times 7x is going to be minus 35x. Negative 5 times negative 3 is going to be plus 15. See, again, we have like terms right here. So 56x squared, see, same. These two added up together, that's going to be negative 59 and 15. Same. So this is just more visual. A lot of people, they'll just go 8x times 7x, and they'll write down 56x squared, and then they'll do 5 times 3, and they'll do the plus 15. But they'll totally forget the middle parts, right? But at least visually here, if you do the area model, you will not forget that because it'll be blank, and you're like, oh wait, I need to fill that out. So again, you choose which way you want to do it. Either way is fine. I'll do right-hand side will be the just distributing, and the left-hand side will be area model. How about we do it that way? So x times x is going to be x squared. X times 1 is just x. 4 times x is plus 4x. And 4 times 1 is going to be plus 4. And so I'm going to just rewrite it, combine like terms. X plus 4, x is 5x plus 4. Done. Nothing to solve because there's no equal sign. All right, we're going to do the second part right here. We're getting close to the end. And I said I was going to use the area model here, so here it is. So n plus 6. Over here is going to be 8n minus 6. So n times 8n is going to be 8n squared. N times negative 6 is negative 6n. 6 times 8n is going to be 48n. 6 times negative 6 is negative 36. This is why it's really important for you to know your multiplication tables really well. It just saves you so much more time. Can you imagine having to use a calculator every single time you're multiplying something? That takes a lot longer. All right, and by the time you do that, you're like, wait, what am I doing? So 8n squared, and 48 minus 6 is going to be plus 42n, and this minus 36. Done. All right, here we're going to just use distribution. 7x times 6x is 42x squared. 7 times negative 5 is negative 35x. 2 times 6x is going to be plus 12x. 2 times negative 5 is negative 10. So we're going to have 42x squared. These two we're going to add up. So negative 35x plus 12 is going to be negative 23x minus. Okay, there we go. And then we're on to the last bit. We're going to be factoring. So the way we're factoring is basically we're going to be doing the opposite. So we know the answer. We want to know what we're multiplying by, right? So this approach we're going to do a little bit differently. We're going to think about how do we get the first term, right? Think about the first term. We did like 8n times n, right? Or we did like 6x times 7x, right? What are those two numbers? And the only way we could get that is 7m and m. If you did m first and then 7m, that it doesn't matter. This order is not going to matter. The second order is going to matter. Okay, so what multiplies to 24, right? So we want just the number of parts, right? It's our bottom right-hand corner. And I'm thinking 6 and 4. Well, here's some trial and error. So I'm going to put 4 here and 6 on the bottom. Now this is what we call the crisscross method. Right, so m times 4 is going to be 4m. M times 6, or 7m times 6 is going to be 42m. Can I use these two numbers, adding or subtracting, to get to 59? No, can't get that, right? So these are not the right numbers. So I'm going to just erase those guys. And I'm going to say, oh, okay, there we go. So I could, instead of doing 4 and 6, I could do 6 and 4. But I know that that's going to give me 7 times 4 is 28, which is a smaller number. And using 6, that's not going to give me that. So I know that 59. So I know that I cannot use 4 and 6. So let me try 8 and 3. So I'm going to put 8 on the bottom so that I can multiply it with the 7. I'm going to put 3 on the top. So m times 3 is 3m. 7m times 8 is 56m. Ooh, I can get this to be a negative 59. But both of them have to be negative, which means 3 and 8 both have to be negative, right? Because that's where they came from. So this would give us negative 59m. And this is the same thing as our middle term. This is our, combined like terms thing, right? The diagonal terms. Yep. So we're good to go. So we're going to just going straight across 7m, not like how we multiplied. 7m times or minus 3 is going to be m minus 8, right? Just to show you this here. M minus 8. Okay, so always your answer is going straight across. All right, let's try it again. So the only way to get 2m squared is going to be 2m and m. And here we got 14, so it's going to be 7 and 2. We're going to have a smaller number, so I'm not going to put the 7 on the bottom. I'll put the 7 on the top. So, that's going to be 4. Yeah, I think I'll get that. So m times 7 is 7m. 2m times 2 is 4m. And I want a positive 3m, which means my bottom has to be negative, which means my 2 has to be negative. That's going to give me that 3m, which is the same as the top. There we go. All right, so we have 2m plus 7 and m minus 2. And again, we're going straight across, just like this. I will say, just make sure, another mistake that I see a lot is, what is it? You just need to make sure also that you see how I just put a negative there? But if I notice negative 2 times 7 is going to be negative 14, so I'm good. You need to make sure that your multiplication, even when you put in the negatives, is going to work for you, okay? All right, so this next one, 79, is going to be 5n and n. Only way to get 1 is just 1 times 1. We're not using any fractions, no decimals, nothing here, okay? And so 1 times n is n. 5n times 1 is 5n, right? I can definitely get a negative 6 if both of them are negative, which means these two are negative. Does negative 1 times negative 1 still give me a 1? Yes. So that's perfect. So this is going to be negative 6n. We're good to go. Oh, we didn't write the answer down, but I just want to write it. Okay, there we go. And so here we're going to go again straight across 5n minus 1. N minus 1. Okay. me just show here that I'm going straight across. Let's not use that color. Let's do this. There we go. Let's use purple. Okay, so 7b squared. The only way to get that is having one of them be 7. So 7b and b. And then 12, there's a couple ways to get 12. So I'm going to use 3 and 4. If I use 3, 4, I'm not going to be able to, because I'm multiplying by 7, I'm not going to be able to get to 8. It's going to be too big. So let me try 2 and 6. I'm going to try 2 on the bottom and 6 on the top. So if I put 6 on the bottom, then I have to multiply with 7. I know that's going to be like 42, way too big. So 6 times b is 6b. And 7b times 2 is 14b. I want this to be negative b, so my 14 has to be negative, which means my 2 has to be negative. And that's going to give me negative 8b, which is the same thing as my middle term. And I'm just make sure negative 2 times 6 is negative 12. Wonderful. So this is going to be 7b plus 6b minus 2. Done. All right. We're going to go to 81. Well, what would be m squared? It seems to throw people off. It's just m times m. That's it. M times m is m squared. It's easier than what we've been doing above, right? What multiplies to 63? 9 and 7, right? So m times 9 is 9m. M times 7 is 7m. And I'm going to have to subtract these. And I want it to be positive too, so my 7 has to be negative. So that's going to be 2m, which is the same as my middle term. We're going to go straight across m plus 9. So do you see how I'm kind of doing it pretty fast? Sometimes you won't come up with the right number, so you're going to have to do some trial and error. So that's fine. You're just going to have to logically reason it out. Okay. Again, we're going straight across. So it's a matter of stamina and grit. You just got to get through it, and you got to think of other ways to get it. So the way to get n squared is n times n. What multiplies to 30? And when it's just n times n, you can start thinking to yourself, well, what multiplies to 30 and adds up to 13? And like, I would not worry about the negatives at this one. I'd be like 6 and 5. 6 and 5 multiplied to 30, but does not add up. It adds up to 11, not 13. Like, I can't use 6 and 5. Oh no. I think this is wrong. Because we can't use 15 and 2. I don't think there's anything else. Oh, so 82, let me just check. 82. Oh yeah, 10 and 3. Oh, 10 and 3. I totally forgot about 10 and 3. Oh, okay, there we go. 10 and 3. My bad. I thought I made a mistake. So n times 10 is 10n, and n times 3 is 3n. Ooh, I've been doing this video too long. This work is messing with my brain. And the only way we can get it to be negative is both of them are negative, right? Which means these are both negative. Now we get negative 13n, which would be the same thing as that middle term right there. We can go straight across, so n minus 10, n minus 3. Again, I'm going to highlight that. Do you have to do this on the test? No. Oh, I didn't mean to follow that one. Straight across. Straight across. All right, we're on our last 2 problems, peoples. Woohoo! All right, so here we go. The way to get b squared, b times b. The way to get 8, ooh, and I want to get 7, so 8 and 1. We can't use 4 and 2. That's not going to give it to me. So that's going to be 8b. 1 times b is going to be b. And the only way to get that to be a positive 7 is the negative b. So 8b minus b is 7b, which is the same thing. So again, negative 1 times 8 is that negative 8, right? So we're good to go. Minus 1. Ooh. And this is us going straight across. We're not going crisscross. It's only for multiplying. Yeah, we're not doing that. It's going to mess you up. All right, so last problem, peoples. Woo! N times n, and this is going to be 5 times 4. That's going to give me a 1 here. So n times 5 is 5n. N times 4 is 4n. And which one has to be negative? It's got to be the fourth smaller one. And so don't forget to add that there, and that's going to be n. Done. We got n plus 5 times n minus 4. And we're done. Good job, peoples. Good job for making all the way through. I would make sure that's weird. I would just make sure that you practice the ones that you don't know. Okay? Practice the ones that you don't know very well. Keep on doing it. Just you can use the same problems. That will help your brain get it better, right? Doing it once is not going to do it for you. All right, have a good one, everyone. Bye.